Hey everybody, welcome back to another fun and exciting geometry class. Today we are going to be starting on page 150. Page 150, we're going to be talking about inscribed angles, and that is lesson 3.14 in your book, 3.14. Well, 3.14 starts off with theorem 42, so let's just jump right into it and let's take a look at it. We already know what inscribed angles are, right? So let's just take a look at this. What is theorem 42? Theorem 42 says an inscribed angle is measured by 1/2 of its intercepted arc. Okay, so we're talking about degrees. Remember we talked about degrees, how they are both for the angle and the arc? Well, here we're talking about the angle degrees and the arc degrees. Now I'm just going to put some random numbers in here so that you can see this. These aren't real. I didn't measure this arc or anything like that. So the inscribed angle is measured by 1/2 of its intercepted arc. Let's say that we know that this arc is 60 arc degrees. Okay, so it's 60 arc degrees. Well, that would mean that its angle that it intercepts is 30. Okay? Notice it says 1/2. Doesn't say that it is equal to. What is it equal to? Okay, if it's at the center point. Okay, so I'm just going to do one right here. So it would be equal there. And that's actually, let's make this look a little bit better because that looked bad right there. So let's make this 80 degrees. Okay, this is going to be better. And so this is a 40-degree angle. But now let's say that we use this right here. We're now using the central angle. Well, the central angle is 80 degrees. Remember, the central angle is the same as its intercepted arc. But right now we're not talking about the central angle. We're talking about the intercepted arc of an inscribed angle. Okay? So now we're talking about the inscribed angle. That's this one back here, not the central angle. So get it out of your mind that it's the same. It's not the same. It's the same from this. Okay? So it'd be 80 degrees from there. But we're not talking about the central angle. We're talking about the inscribed angle. It is 1/2. Super important concept right there. I mean, like, mega super important concept right there. Like, half of your test is based on that concept. Okay, so you better learn that concept. Super important. Um, 1/2 of the intercepted arc. Now, so what does that mean? Well, it means some things. We can figure out a whole lot of information from this. We really can. If you look in your book, you'll see what I'm doing right now. But if we do connect that, let's say we actually connect that right there. Well, we know something about CB. We know something about this angle, CB, COB. Okay? We know that it's 80 degrees. Why? Because the arc is 80 degrees. Because I told you the arc was. How did you know the arc was 80 degrees? I told you it was. It was part of the given. Okay? So we know that. Now, I want you to see something else. We know something else. Check this out. This is awesome. Okay? I like awesomeness. So let me zoom this up just a little bit right here. What else do we know from that? Well, let's take a look. Look at this line. That's a line. That's a straight angle right there. What do we know about straight angles? Straight angles equal 180. So what do we know about this reflex angle, or what do we know about this exterior angle right there? Okay, we know that it must be 100. Well, what? Wait, how'd you do that? Because this is a straight angle. Okay, straight angles equal 180. If one side of your straight angle is 80, then the other side is 100. It has to be. Okay, now what do we know? Now we also know this angle up here. What is this one up here? Well, that's a triangle, right? Don't we have a triangle? Look, A, C, D, that's a triangle right there. So triangles always equal 180. So if we have 100 and if we have 40, then we have another 40. Wow, how else should we have known that? How else should we have known that? Okay, watch what we have right here. We have a radius and a radius. What do we know about radii? They're all equal. Okay, so what kind of a triangle do we have right there? So if this is equal to this, then we know that this angle is equal to this angle, y. okay, because of isosceles triangles. Yeah, you got it. You're getting it. All right, so now look at all the different things that we have. We have a lot of different things. What else do we have? Whoa, one more thing. We have that arc. What is that arc? The intercepted central angle is 100. So that's 100 arc degrees. What else do we have? Well, if that's 180 up here, look what we have down here. We have 180 down here. That's a semicircle right there. Okay? And so we know that we now know that this is a diameter. How do we know that's a diameter? Definition of diameter, it cuts a circle in half. What's half of a circle? 180 arc degrees. And so we just figured out a ton of stuff about that circle based on one thing. Remember when I said how important this theorem is right here? I said it's half of your test. I'm not lying. Okay? You're about ready to unlock Pandora's box. If you know what Pandora's box is, it's where there's like mysteries and all kinds of weird stuff. You don't want to know what's in Pandora's box, okay? Well, what's inside Pandora's box is like all of these mysteries are going to come out. Theorem 42 is the key that unlocks that, okay? So now, once we have the box open, now all kinds of things are going to be able to come out. We're going to be able to figure out all sorts of different things because we know this. This is such a key to the rest of this chapter right here. Okay? You should love that theorem. You should like take it out to dinner or something. I don't know, buy it a ring. I don't know what you need to do, but you should love that theorem. All right? Do your best with that theorem. Okay? Memorize that theorem. Super important. I'm not joking about this. All right, now this is what's called case number one, case one. In case one, notice what happened with the intercepted, with the angle. The angle passed through the center point, okay? The angle passed through the center point. Now, this is case two. Let me shrink this back down just a little bit. Here's case two. What's case two? Now look where the center point is. The center point is not, on the other one, it was right in the diameter, right? The angle was. Now it's not in the diameter. Case two is where the center point is inside of, look, it's inside of my angle. Here's the center point inside my angle. Here, the center point was on my angle. There's the center point right there on my angle. Okay, so now this one, case two, is where the center point is inside of my angle. And you can see that is on page number 151, page 151. Now, are the same things true about this? Yes and no. One thing is it doesn't work anymore with the whole thing because we don't have a diameter, so we don't know the 180, we don't know a lot of the different things. So a lot of the things that were true about case one won't be true about case two until you can get a diameter to go through there, until you can locate what the diameter is. Or maybe it's part of the given, or who knows, so you might have to actually do some more work connecting dots and lines and things like that. So, but we do know that this still is 1/2 of the arc degree. So let's just give you an arc degree. Let's say that this arc degree is 130, 130, okay? So what is the angle degree? If the arc degree is 130, well, it's half of 130. What's half of 130? I think it's 65, all right? If it's not 65, then you need to find a new math teacher, okay, because he messed up. So half of 130 is 65. So that's going to be, remember, you always write degrees so I don't get confused with your answers, what you're trying to tell me. So 130 degrees and 65 degrees would be the intercepted arc, or intercepted angle. Inscribed angle, not central angle. Don't get confused between the central angle. Another way that we could work on this is by doing that. We now know that that one is 130. But notice we don't have a triangle anymore. Remember when I said it's not as easy anymore? So now we don't have a triangle there anymore, so we can't use all the same theorems and axioms that we used before. But that would still be a 130 angle right there. Okay? All right. Case 3. Again, this is in your book. Now look at where the center point is. The center point is now outside. So we started with it on the angle, and then we went to outside the angle, and now it is, or we went to inside the angle, and now we've gone to outside the angle. So now what do you notice about this? Well, the same thing is true if we draw our angle here to the center point. And look what we've created now. Now we do have some triangles, don't we? Look, we've got some triangles. Now those triangles are not congruent, but we're going to learn, we're actually going to learn a lot of stuff about those triangles right there. Okay, we're not ready for that yet, but notice there are some triangles there. All right. But what do we know about this? Let's say that this now, we know that this is 50 degrees. Okay? We know that that arc degree is 50. Well, we still know that that angle right there is going to be 25 degrees. Why? Because it's half of the intercepted arc. If the arc is 50 degrees, then we know that the angle is 25 degrees. All right, so that's case 3. That's when we have the point outside of the angle. Case 1, point was on the angle. Case 2, the point was inside the angle. In case 3, the point is outside of the angle. All right, we're still on page 151. Corollary 42.1. Corollary 42.1. All angles inscribed in the same segment or incongruent segments are equal. Interesting. So what does that mean? Well, let's inscribe an angle. Let's take a look at it. So it doesn't matter where we inscribe the angle. We'll inscribe it like this. Okay. The book right here is saying, Corollary 41 says, all angles inscribed in the same segment or incongruent segment. So let's go ahead and label this. Let's call this A. That's not an A. Let me try again. That's an A, B, and C. So right now, this angle A is inscribed in this segment. Okay, remember what a segment is. Okay, that's a segment right there. Okay, so it's inscribed in that segment. Let's give that a number. Let's give it a that looks more than 120 degrees. I don't know. I'm just making stuff up. So actually, it's less. It might be 120 degrees. And so this is going to be 60 degrees right here. Now watch this. If I draw another angle, now look, I'm in a different place now. So now I'm looking at the pink angle. But notice that the pink angle is still subtending the same arc, BC. So what do we know about this? And we'll call this one D. What do we know about angle D? Well, angle D is also 60 degrees. And we can do it again. Do a straight line. And that one's to B, and that one's to C. And so we'll call this D. Well, we know that D is also 60 degrees. How do we know that? Because it's also subtending the same arc. Okay? And that's what that's saying. All angles inscribed in the same segment or congruent segments are equal. So if we put it in this, if we inscribe it in the same one, in the same segment, then it is going to be equal. Let's see what else. An angle inscribed in a semicircle is a right angle. All right, so what does that mean? Well, let's do a semicircle. What is a semicircle? Semicircle is a diameter, half of the circle. All right, so there's our semicircle. Now let's inscribe an angle in that. What does that mean? Well, it doesn't matter where you do it from. That's a 90-degree angle. How do we know? Because what arc is it intercepting? It's intercepting a 180. So what is its measurement? Half of 180. That's a 90. So what do we have there? We have a right angle. Cool. And it doesn't have to be just that. It can be somewhere else. So we could go over here and we could say, okay, so that to there and that to there. We have another 180. Why? Because it's subtending the 100. We have another 90-degree angle, sorry, because it's subtending the 180-degree arc. Okay. So that's a pretty important corollary right there. You're going to use that one quite a bit. All right, and the last one, corollary 42.3, an angle inscribed in a segment less than a semicircle is obtuse, and whose segment is greater than a semicircle is acute. Now that's interesting. That kind of seems backwards. So the angle inscribed in a segment less than a semicircle. Okay, so let's inscribe one. So let's put a segment on here that is less than 180. All right, that segment right there is less than 180. What segment am I talking about? I'm talking about this segment right here. Okay, so if we inscribe the angle inside of that segment, this is what it's talking about. So let's go ahead and do that. Let's inscribe one, and it doesn't matter where we put these. We're just putting it inside of that. So now look, if I inscribe it inside of that, see, what am I really doing? If I'm inscribing it inside the segment, here's what I'm doing. I'm subtending the big one. I'm subtending the major arc. Okay, because if I inscribe it inside of the small one, I'm subtending the big one. Okay, does that make sense? So now I'm going to have an obtuse angle because I'm going to be subtending something that's much larger than 180. Okay, now let's do it the other way. Let's say, and here's the other one. If you inscribe an angle whose segment is greater than a semicircle. So now let's talk about, didn't mean that. Let's do it the other way. So now this segment, let's use this segment. Let's use the big segment, okay? And because it's greater than a semicircle. So let's inscribe an angle in the big segment. Well, what do we have? We now have an angle whose less than, it's going to be acute. So if we inscribe it in one that is bigger than 180, we're going to get an acute angle. Why is that? It's the whole half angle thing. So yeah, that's what that theorem says. That's not a super important one, but you'll use that one. You will use it, but it's not quite as important as the other two or three that we've talked about today. All right, well, that is all I have for you. Try some of those practice problems and see what you can do with that. If you missed anything, make sure you go back, rewind it, and take a look at it. All right, we'll see you later. Have a good one. Bye-bye.